I thought I heard
Yeah,
girl.
but I have one of each, so.
Awesome, congrats.
Yeah, thanks. It's way better than being pregnant.
Yep.
Okay. I am in the quiz now, finally.
Cool. I'll get over there.
The stuff is not very easy for me.
Yeah, it's getting harder.
Yes, it really is.
Okay.
Find the directions of which function increases and decreases most rapidly. So, for this, do we just do the partial derivatives and then put the points in, right? Oh, yeah, yeah.
Yeah, the second derivative test, is it? Is that what we're doing?
Not yet. Maybe later.
Oh, right.
But
I'm getting ahead of
the first
myself.
one is just, at least, yeah, I think so.
What direction does it increase most rapidly? So just be where the derivative is the highest. Wait.
Yeah, okay, so for these, I always just put in the numbers and it worked, but I could never make it. So for instance, down there, it's going to ask, like, where does it equal 4 or something? So that's not on this question, but on the homeworks, I can never figure those out.
Okay, so we plug in P0 or do we solve for 0? I'm confusing myself.
So for this one, we plug in P0
okay.
in all of the partials.
Oh, okay. Or wait. Now I understand what it was saying. Okay. I get it now.
Okay. Remember this part?
Vaguely. I've not been sleeping well the last couple weeks.
I'm sorry.
Granted, I'm one to talk.
You know what? This baby slept through the night last night, so
It's a miracle.
I'm telling you, he's the best thing that could have happened to me right now. Yep, he's been pretty awesome.
Oh, wait, I'm an idiot. Okay, I know what I'm doing. What do I do?
Okay.
It's going to be one of these days.
What did you get? Have you gotten any of the partials yet?
Have f sub x. And should be a second away from y and z.
Okay.
Wait, why is what? Wait. What? I feel like I'm missing something. Is there u's and v's? I don't know where they're coming from.
X and Y being the same. And then Z is different. Is that what you have?
I am so confused. That's what I get for doing the homework while tired.
So my X and Y are equal to 6, and then Z is equal to 4. But I haven't put it, that's not putting it over the magnitude yet. What? Hi. Sweetie, I'm doing homework.
Okay. Walk me through finding x. I am like crazy lost.
Did you get 6?
I don't know how I'm approaching this.
So the partial, if you look at
oh wait, it's the whole, it's not a vector, it's just a number.
No, it's just a function. Yeah, that's
what I'm doing.
Would make a big difference. Okay. Yeah, I just about did that too, actually.
That explains a lot. Okay. That'll do it.
Yeah, that would change things.
Yeah. Then why is x 6 if? So we're taking the partial derivative in respect to x, which would be...
Yeah, so...
Unless I'm like...
I got 4 over x plus 2 over x.
At point 1, 1, 1? 4 over x?
Yeah, so I got 4 over x plus 2 over x, but since x is 1, it just equals 6. Makes sense?
I don't know where the 2 is coming from. I had 1 over x plus 3 over x.
1 over x plus 3 over x. Are we doing the same problem?
Question 1 on the week 10 group quiz.
Yeah, let me make yours bigger though. I don't even have a 3. I have 4, 2, 2.
I have 1, 3, 3.
So we don't even have the same problem.
Question 1.
Pretty sure. Let
Week
me
10.
see. I did. Yeah. Week 10 question 1. It's the same question with different numbers. Like
that's rude.
So that's why we're so confused.
Yeah, okay. Good. I'm not doing this like 200% wrong.
No. Okay, so then yeah, you're probably right where you were. Okay, I'm just gonna put in these answers and see if maybe I line up with a different question. Those. Nope, 2 is completely different. Oh, okay. I guess as long as we're doing the same process, hopefully we get the same thing.
So our numbers will just be different, which is weird.
That's a pain.
And the minimum would just be the negative of those numbers, right? -4.
Yep. Over the magnitude of them.
Over the magnitude. Meaning what?
So like
direction. So, but it's not a vector though.
No,
Unless
but it's
is it
asking
vector?
for a vector. It's asking for a unit vector.
Yes, it is.
So
yes, you're right. Okay.
magnitude.
Okay.
And then the value of the derivative is the magnitude, if I remember right.
Right. Wait. Wait, the derivative with respect to u of f? What?
Yeah, I just remember it being the magnitude. I can't exactly remember why. Well, I guess that makes sense because the derivative would just be a combination of the 3, right?
It would be the total derivative is a matrix. Also, it would probably be the determinant of the matrix, which is the magnitude.
Yeah. Okay, that makes sense.
Okay. Okay. I need to
And
panic.
then the other one's just negative.
Yes. Okay, that makes a lot more sense. On to question 4.
Let's see if we have the same numbers for this one. What are yours?
X cubed, y cubed, 6x squared, minus 3y squared, and -9.
Nope, my 6 and 9 are mixed, so I have 9x squared minus 6, but whatever.
It's not nice for group quizzes.
Why would you do that?
He wants to see us infighting.
So for this one, don't you find the x and fy, and then you set them both equal to 0? I'm really not sure how to do this.
So we want to find the second derivative. So we would find the Hessian form, which is the 2x2 matrix of fx, whatever. And then we would find all the places where or then we would subtract the, not sigma, but whatever, lambda. From the diagonal, top left, bottom right. And we would solve for lambda and then find where lambda is equal to 0 or something.
Okay.
Or yeah, we'd solve for lambda, and then it would wait. That doesn't give me the whoa. No, don't do this to me. That's not nice. Wait. That was mostly right. The lambda tells you if it's positive or negative at a spot.
Uh-huh.
So we probably want to determine it and then set equal to 0 to get the points of interest.
Sure, let me see.
That's a question mark. That was a, I'm guessing.
So I remember reading about that, but when I was doing the homework, we did one of these. I don't think they did all that stuff. I guess it probably is better if we figure that out.
Yeah.
Just do it. So the only thing that would be different for us is our f sub x. Well, not necessarily, I guess.
Yeah.
Okay, so fxx is 6x plus 18. 0. So in its examples, it has like just numbers. It doesn't have functions.
Yeah.
A function subtract.
So you would just subtract the variable from on the diagonal.
Oh, we need to find the critical points first using the first derivative.
Yeah.
Okay.
Wait. I remember it said the first derivative test breaks in 2 dimensions. I'm going to look that up in the notes because it says that in my notes, but I want to make sure I know what I was talking about.
So the one it says for the function, the gradient is this, which is 0 at. So you find the 0 first. Critical points in the Hessian thing.
Probably Hessian.
Who knows? Because there are 2, we have to find the eigenvalues of 2 matrices. Find the critical points using the first derivative.
Oh,
then
wait.
You put it in.
Wait.
Because then there's the 6. So.
First derivative breaks down higher dimension.
Oh, wait. Okay.
Or maybe it was only saying that like you can't use the slope of the first derivative there. So you have to use the second derivative test. I think. Maybe. Yeah, I'll still set it equal to 0. Oh, wait, but okay, so we can. Oh, never mind. Wait. Yeah, I'm getting ahead of myself. I'm probably wrong. Today is not my day. Wow.
It's okay. Okay. because there are 2 critical points. Find the eigenvalues. What if there are 4 critical points? Then do we have to find the eigenvalues of 4 different things?
All right, do any of the points overlap? Or I guess it's some are x's, some are y's, if you're doing it.
Yeah.
Huh.
Maybe.
I don't know if it said that we specifically had to do that for this. Like,
I have no idea. Well, because I found critical points, but the only way to see if they're maximum or minima is using the eigenvalue, right?
yeah. Or I mean, to solve for the, I'm assuming it's lambda. I don't actually know.
Oh, wait. No, you just plug it in.
Yeah, you just plug it in, I think. Set the determinant of it equal to 0 and solve for the lambda. I went to all the wrong screens.
So if one's negative and one's positive, it's a saddle point.
If one's negative, one's positive, it's a saddle. They're both positive. If they're all positive, it's the thing. If any of them are 0, then it doesn't exist. Which means that probably none of them
So
would be 0.
0 is a saddle point, I think. Actually, would we have the same?
I mean, one of our numbers on the x is slightly different. I have a 12 instead of an 18.
But it would be the same whether it's a minimum or a maximum.
Probably.
I see what you're saying. That wouldn't work. Because our critical points should be different, right?
Mm-hmm.
Oh boy, let's see how this works. How do you find the values of the local maximum?
I don't know. Because I'm like getting all sorts of variables.
Yeah, this is not.
Makes me think I'm doing something wrong. Because it's going to be a value. So how do we solve for x? Notes help. Ugh.
Okay. don't know how to find the values. I guess would you just plug them in?
Probably. Okay, here's an example with an x in there.
Sure. Would you plug them into the original equation or not? They could be totally wrong, but I have points.
Give a minute, I'm out of commission.
-6. -10.
Yeah, we'd probably solve for y or x in the original and then... Wait, but that'd be weird.
I don't know. I guess, I mean, I wouldn't know what else to do, so maybe I'll try that. 50% on this quiz, I get 50%.
Yeah.
I'm pretty sure. Okay, let's see if I did that right. 0, 8, 0.
I mean, actually, wait, but in order to do that, we have to know a value ahead of time.
For what?
If we're going to solve for y or x in the... Oh, no, we don't. Just kidding. We can just set it equal to 0. And we'll get the y-intercept. We need 2 equations. I call shenanigans. Oh, wait, we have to use gradient. For something, a gradient is that to find the critical points. To find the critical points, you set the gradient equal to 0. The 0 according to the matrix that we need. Okay.
Yes, that's what I did do that for the critical points.
Okay. Now I'm catching up.
Oh, glory. Right. Okay. I thought for sure he had a temperature example.
Okay, if I'm understanding it right, the gradient is the partials added together.
Sorry, say that again.
If I'm understanding right, the gradient is the first degree partials added together. I'm way out of it.
Yes.
Okay.
I'm pretty sure anyway.
Okay, there's a chance I know what I'm talking about, maybe. Probably not. I'm sorry, I'm so useless this week.
Oh, no, no, no. I don't know what I'm doing either. I'll be right back.
Okay.
I'm back.
Okay.
How's it going?
It might be going. I'm not sure yet.
Okay.
I haven't decided if it's going yet.
You're better than me. I just put in numbers and pray that they're right. I think they are. My house is a little bit crazy. My daughter found a kazoo. Never a good thing.
That's awesome.
Yeah.
Trying to figure out how to set this darn gradient equal to 0 and not get like multiple dimensions of variables on both sides.
I got 2 x's and 2 y's, so I had to do 4.
I mean, I'm trying to figure out like how that works algebraically to equal 0, because I can get like 1y equals x times x plus 4, or the other 2 minus y equals x times x plus 4, but that only works.
Do your partials have both 0 in them? My partials only ended up with one.
Oh, you were doing it like
variable.
The gradient with respect to x and the gradient with respect to y. Oh, because it's
they only ended up with one variable.
I switched up which my wait, what do you mean it ended up with one variable each? Like the y's only have x's.
Like meaning my fx is only 3x squared plus 18x. Y doesn't exist.
I was pretending I could do a full derivative, I guess, and I can't.
That might make it harder.
Yeah, that's why I was struggling. Trying to do it all at once. It's not how it works. Would you have to plug those, like plug the x's back in to get the corresponding y's for the point?
So what I did is I got the critical points from the first derivative.
Yeah.
And then I plugged the critical points into the second derivative, like one at a time. So I had 4 different.
But 2 of the second derivatives were 0.
Yeah.
Like
so I just plugged them into the other 2. And then it ended up like one was positive, one was negative for one set, and then actually for 2 sets it was like that, and then for one set it was both positive, and for one set it was negative. Does that make sense?
Yep. So you just set the partial derivatives equal to 0 then. Okay, I think I understand what I'm doing wrong. So your numbers would be like 0, 0, -6, 0, 0, 2, negative 6, 2?
Yes. Pretty much. Okay. So yeah, I have 0, negative 6, 0, 2, and then yeah, you just put them different ways.
Oh, my x's are have negatives. Your y's have negatives?
No, my x's have negatives. Do we have the same numbers?
Okay. No.
Maybe we should. Maybe we shouldn't.
We had like two things that were. We had two numbers that were switched. So I have a 6 where you had a 9.
Yeah, yeah.
Okay. You plug those numbers in. Okay, so there's a maximum, a minimum, and 2 saddles?
Yeah, that's what I got.
Okay. And our numbers are different, so.
Right.
Let me see. And when it asks for the local maximum value, it's asking for the lambda, right?
That's the one that I just plugged back into the original. Whether or not that's what we should do.
Oh.
So yeah. Like I took that ordered pair and put it back in the original.
Probably right. Okay. Original was that. I have numbers.
Right,
Hopefully they're the right numbers. Let's move
awesome.
on. Now it's a temperature problem.
Yeah. So, do we do this the same way? Find a maximum and a minimum?
Yep.
How do we incorporate T? Is my question.
Unless this is an optimization question.
What did I do with my pen?
It might be an optimization question.
Sorry, what?
Unless it's an optimization question.
It is, but it has a restraint. How do you include the restraint?
There was the Lagrange multipliers part of the reading. The second part from today's reading, or second set.
Right. Okay. So the gradient of L is supposed to equal 0? Or, yeah, the gradient of the constraint, I think.
Possibly. I'm going to look at the reading. My notes are
me too.
leaving a little bit to be desired.
So we need to make it equal to 0.
So G is the constraint. L is F minus lambda G. I want to know where.
Yeah. Okay. And G needs to equal 0. The constraint must have the form, so you're right.
Unless you like do partials constraint.
Well, so it says the Lagrange multipliers to constraint must have the form G of x, y, z is equal to 0. So we write it equal to 0. The Lagrangian is equal to the function minus lambda times that. So then you find the partials of L. Okay, that's a little bit confusing, but it makes sense when you read it.
Yep.
Let's see this. Wait, do you make f of x equal to 0 as well?
We would need to find the lambdas. Like we'd have to do the last process as well. Still need the lambdas for the L equation.
Yeah, when he did it in the work though, he just left the lambda there. And then he solved for lambda later.
Maybe we'll.
I said all the partials equal to 0.
Let's just do lambda later then. We will do this thing instead.
The only thing with his example, it just has f of x, but it doesn't have it equal. Ours is equal to 1, so do we just move the 1 over?
Probably.
Make it equal to 0?
Yeah, I think that's what you do. X squared plus y squared plus c squared minus 1 is 0.
Oh yeah, do we have the same numbers this time?
And it's your t 900, although you can just cancel out. We set t equal to 0.
No, my t is equal to 100 x, y, z squared.
Mine is 900 x, y, z squared.
Cool.
But
at least our 0, f of x.
Wait, which one's the constraint?
Oh, you're right. I'm pretty sure t is the constraint.
So t outputs a temperature. No. Wait.
It says the temperature on the sphere is equal to x squared plus y squared plus z squared.
Looking for temperature as our answer. Would the sphere be the constraint? What?
Oh, I see what you're saying. I see what you're saying. Yeah, I think the sphere would be the constraint, so that does need to equal 0. Huh.
Okay.
That will make a difference.
So
that is going to be multiplied by lambda. And then 100 xyz squared.
No, 900. You're wrong. This is not going to get confusing at all.
For reals. Okay, and now we have to find
L. So what did he set the partials of t? What would be t equal to 0? Or did he do shenanigans before that?
Let's see. So he found all the partials. Now we set each partial equal to 0. Yeah, this gives a system of 3 equations but 4 unknowns. Okay. Not sure this makes a ton of sense. Then it says to just solve the system of equations.
Hmm.
But I'm not sure this is giving us the right answer. Because his example is maximizing a volume, or yeah, maximizing something.
Well, we're maximizing temperature.
Yeah. His example isn't, so I don't know how we need to.
We just get we get a 3x3 matrix this time as our the Steve matrix, Hessian matrix thing.
Either one, yeah.
So it's 3x3 this time. And we still set the determinant equal to 0. No, we'd still. Hold on that. Could I have an example maybe in the textbook of a 3x3? And by textbook, I mean it's a page on Learn.
Yeah.
Nope, only 2x2s. So either we're not supposed to do 3x3, which wouldn't make sense because it's just another dimension.
Yeah. I don't really understand. Okay, so
we'd still go along that same
formula at the beginning.
The what? Sorry.
The very beginning thing that said, where am I looking? L is equal to F minus lambda G.
Yes.
Is L going to give us, are we looking for L?
Mm-hmm.
Will that give us the temperature?
The optimal solution will be where gradient of L equals 0.
Okay, so now we found L. Now we're using all of those to equal 0 to get the X, Y's, and Z's. Okay, so we are doing the right thing. What did I just do with my pen? I'm losing my mind.
I feel you.
Okay, for reals though. How far could it have gone? I was just using it. Okay.
Okay, we're doing that, though, making it way harder for myself again. No.
Oh, brother. I'm not very good at systems of equations. Sometimes I just go in circles.
Yep. Wait, so we set the partial is equal to 0. Wait. Maybe the temperature was the bound after all. It's looking like that might be the simpler thing.
It's to do what?
Maybe the temperature was the limit or the constraint? Question mark.
Wait, say that one more time.
Maybe we have the constraint and the non-constraint mixed up. Although I think the temperature.
No, I think we've got it right.
Because like the numbers would be, because like when I have 900 yz squared equals 0, then I'm just deleting variables when I try to algebra it. I'm going to try it the other way and see if it works out.
So x and y are equal to each other, I think.
But they have, dividing x, or like dividing z squared by 0 just deletes the z squared from that equation now. That's my issue with it. In order to isolate the x, you can't subtract when they're being multiplied by each other.
Are you talking about the partials?
Yeah.
Yeah.
You'd set the partials equal to 0 and then use that to get your things to plug in to get the lambdas. And I think that that's just not working.
Yeah, I got lambdas equal to 100xy.
There should be more than one lambda anyways.
There should be?
Mm-hmm.
How are we supposed to solve a system of equations if they're two different lambdas?
That's what I'm saying. I think that we have to do the other way around if we're going to be able to solve the system of equations. Because before we use the fx and fy set equal to 0 to get values for x and y to plug in. We had 0 equals, in my numbers, 900, or yours would be 100
to get these
y
partials,
z squared. That doesn't really work.
To get these partials, we multiplied it by the same lambda. Didn't we?
I had, I set dfx equal to 0, or because the gradients were equal to the partials. Kind of. It could be crazy.
You could not be crazy too, but I'm not sure I understand.
Because I don't know how we're going to get a value to plug in for the x, the y, and the z to be able to solve for lambda in the first place.
Let me see.
Because we only have one equation of lambda in it at the end of that, which should give us multiple values for lambda. Because we need at least 2.
Got it.
And I think because it's all multiplied together, we can't ever solve for x, y, or z when the other side is equal to 0. Unless we divide by 0, but that's generally discouraged. So I think our very first train of thought was right, and then I overcomplicated it, and now everything is going to evil and stuff. And I'm just throwing words at the wall now.
There was one thing that you mentioned in the end. Let me see. You have 4 unknowns, 3 systems of equations, but if you use the constraint as one of the equations, you should be able to find all 4 unknowns. And we decided x squared plus y squared plus z squared is our...
We decided that was our constraint.
Yeah, okay.
So maybe we do... So maybe we can just get the x, y, and z from the constraint, because this is different than the last problem we had, and I'm overthinking it. That's probably what's going on.
Oh, maybe I need to make... Oh, right here, very sad baby. Dang, that didn't work.
Oh wait, are we way overthinking this and we don't have to optimize it? We set like t of the other equation.
Maybe so.
So
well,
like
we kind of have to optimize it, don't we?
Because then we can get a gradient with that.
Let's just try that.
Yeah, that sounds like it's easier.
So f of t just a second.
All right, we just have to figure out what.
Okay, we're almost done. We're stuck on the last problem. But bring him up when you're done, okay? So are you finding the gradients of f first and then plugging t in?
I'm trying to figure that out now.
We might be overthinking it because I feel like you had an example on this, and maybe it's before we learned optimization.
Okay, so what I was thinking of, if C is a level curve of the function thing, and RT is parametrization, then composition equals constant C. So f of t would equal. Wait, but t isn't necessarily a parametrization. It's just a equation that has. It's just a different equation. Darn it. And I think you might have been right before. I don't know. I'm so confused.
Yeah, I don't understand it. Okay, but I did just find something in an earlier so if the temperature at a point on the plane is given by T equals this, the only problem is this one actually gives you yeah, that doesn't work. Somehow we have to optimize it, but
okay, so it was optimization. I think that we switch around what we were using as a constraint. Find the partials of the.
maybe, but I think that your logic was right because the temperature is not It doesn't ask us for the
For the thing.
I don't know what I'm trying to say. So if temperature were constrained, then it wouldn't be asking us what the highest temperature and the lowest temperature are.
That's us for the highest
sense?
and lowest on a sphere, which might make a difference.
So
they gave us an equation for a sphere,
I guess.
an equation for temperature on that sphere. No, wait, no.
Okay, so I guess that could be the restraint as well.
Yeah. So I think T is the thing. Plus, it also gives us a much nicer. It gives us a nicer thingamajigger. Ugh.
So are you doing the same thing we were doing, but switching the
equations? Yeah.
functions? Okay.
I got for my lambdas 2 and 2 and 2. Because I got rid of all the variables, which might not be desirable.
Huh. Well, I don't really care. Maybe we should just put numbers in at this point. But that wouldn't work for highest and lowest.
That means this is telling me that there isn't a lowest. That's not right. That's not right. There is a lowest. Something went weird. That isn't correct.
Have a good night, my baby. I love you. Will you take the necklace off before you put her down? Also, her blankets are in here, Sheldon. Oh boy.
Maybe we were right the first time.
I wasn't getting anything the first time.
I know, but maybe we were still on the right track. We were just looking at it wrong. I still haven't like multiplied out or done the determinant because there's a lot of numbers and I was intimidated. I don't want to.
He didn't even do that in the example. That's the problem I'm having.
Yeah. But I mean, it's definitely lambda. There's definitely a lambda in L. Oh, wait, unless lambda is just always 2. Wait. That's just maybe. It'd be weird if there was more than one value for lambda, wouldn't it? Because then there'd be multiple optimal
I was
solutions.
thinking so.
The way
it has to be the same.
The way we just did
but
it, I only have
we
one
can
value
get different. We can get different x, y's, and z's, which I think that's what we're looking for, right?
Yes. Okay. So lambda is 2.
Should be. Oh, so lambda's 2. Then we can probably solve the rest of it.
Yeah. L equals F, which is squared plus y squared plus z squared minus 1 minus 2 times g.
How did you get lambda to be 2?
I multiplied out all the partials, put it into a matrix, took the determinant, and all of them were equal to 2.
Okay.
Because the second derivative of x or y or z is going to be 2.
Right. Okay, so if all those are 2s, those are all 4s. So 100xy. Lena, get back in your bed, sweetie. Yes, honey. Oh boy. Mommy's doing homework. I'm almost done, baby. I'm getting ridiculous numbers. What are you getting?
I have just for my L equation, like not it. I don't know what.
For your... Well, for like the gradient of L. Do you have?
Oh,
well, you would have 9.
You would. Or why are we taking the gradient of? Oh, because we need the gradient of L. That's what I'm doing wrong.
To get the x's, the y's, and the...
That's why our numbers are. I'm trying to figure out how I'm supposed to do this. I'm doing it wrong. There's my problem.
Lena, go lay down.
It's like for my x, or in your numbers, it would be x minus 100 yz squared for L sub x.
I have 100 yz squared minus 4x, yeah.
What did you multiply?
I put lambda in already as 2. Because isn't it
what did you multiply by
minus?
2?
Huh?
You would multiply g by 2. So that would be your 100 xyz squared. G. Or this t.
I thought we decided it was the other way around.
No, we switched it this time because it wasn't working last time. Last time we had f as the t and g as the other one. This time we swapped it to see what would happen.
Okay, so what should I have? 2x minus 400 yz squared, or minus 200 yz squared?
Yeah.
Okay.
That's still not a nice number, but...
That would make 2x is equal to 200 yz squared, which would mean 2y is equal to 200 xz squared. How does that even make sense? Unless z is really little.
Z will be bigger than x and y. But possibly. Unless it's just a really, really hot sphere. They didn't say what it was made out of. The sphere is actually made out of, like, plasma. It's actually the sun.
Maybe that's what, with the radius of 1.
Of 1 solar length.
That'll work. Lena, stop. I might just put numbers in and go.
Yeah, that's what I'm doing at this point. I'm plugging stuff. I'm substituting between them now, seeing what explodes.
Yeah.
I mean, 1800 squared times 900 isn't that hot.
Yeah.
I mean, there's only 1, 2, 3, 4, 6.
Lena, stop hurting yourself.
It's only like 3 billion degrees.
Yeah, I'm just gonna submit this. It'll be interesting to see what the actual answers are.
Yeah.
Oh, I missed one thing on question 2. What one did I miss? Hey, that's better than I thought, though, not gonna lie. Oh man, I just switched the 2. Duh. Cool. And last one, yeah, not even close. Cool. Okay, I better go, but thanks for meeting.
You're welcome.
And I will be good to meet next week. Do we have to meet next week? It's Thanksgiving.
I don't know.
I guess we'll find out.
Yeah.
I'll check. Okay. Well, thanks.
I got everything. Wait, what? Did you get 1 right?
I got 1 right.
I got nothing right on 1. Well, that's rude.
Did you?
Apparently it wasn't even remotely close.
That's weird.
Like I answered, like for my U, I answered 1, 3 halves, 3 halves. It was 2 over root 17, 2 over root 17, 3 over root 17. Because you know that makes sense.
Okay.
Oh well.
Well.
C'est la vie.
Whatever. I will see you next week.
See ya.